Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
All right, we're going to start off by looking at the study guide A, which is covering the circle graphs, and I believe association might be also a part of this. All right, why am I going up and down? Sorry. So here's a circle graph. It's got 4 names: Alicia, Barbara, Camille, and Dominique. I wonder what this is about. It says problems 1 through 3 use the circle graph at the right. The graph shows the results of 1,200 votes for prom queen. Oh, got it. These 4 ladies were running for prom queen. So who won the election? Well, Alicia appears to have gotten the highest percent of all the votes because her wedge is the biggest. Did the person who won the election get more than half the vote? I would say no, because if she got more than half the vote, let me draw a line there for the halfway point, the wedge would be beyond that point, and it's not, so no. And then it says, approximately how many votes did Camille receive? All right, so let's check this out. Let me draw a line here, like that, and let me draw this line like that. Could this be, no, I don't know. I don't think that's right. Could this be one of those situations where it's kind of like a star? Something along these lines? Yikes, that's a little tricky. Hold on, maybe this one does belong a little bit more like that. All right, so I'm guessing that this is about 1/5. It's kind of hard to tell. But if I were to break this down, let's once again go like the halfway point. This looks like it's a bigger wedge, so this is bigger than 1/6. Because if we broke up those into 3 equal parts, this would shrink a little bit, that one would grow a little bit, and that would be like 1/6. So let's say, I'm going to just say it's 1/5. And so 1/5 of 1,200 is the same as saying 20% of 1,200. So we could do it either as we could do it as 1/5 times 1,200, which becomes 1,200 divided by 5. 1,200 divided by 5, 240 votes. Or if you had done it as 20% of that, the decimal equivalent, 1,200 times 0.2 is also 240. So we're estimating Camille's vote tally as about 240 votes. But that is just an estimation. If you got anything in the 200 range, I would say, yeah, okay, that's pretty close. Right, now for an entirely new kind of a problem. It says, of the milk consumed in the United States, 30% is whole. So that would be 30 out of 100 is whole. 50% is low fat, so it would be 50 out of 100 is the low fat. Let me put the W there, the low fat is there. And then the skim is about 20%. So it's 20 out of 100. So if we wanted to, we could have done this. Change that to 3 out of 10, 5 out of 10, and no, we don't need to do that. That's totally fine. We just leave it like this. Now, if we are using our protractor to figure out all of this, then I would say every one of these needs to be converted to a number out of 360. And our giant one, we would multiply each one of these numbers times whatever you multiply times 100 to give you 360, so that'd be times 3.6. And then you would get the appropriate number of degrees for this angle, and for that angle. Nope. Yeah, okay, so let's figure out what those angles are. 30 times 3.6 is 108 degrees. So whole milk is about 108 degrees. 50 times 3.6. No. That's going to be 180. And that's right, 180 degrees is a straight line. And then 20 times 3, so that's going to be 72 degrees. And so this would be a 72-degree angle. So you could do it like that. Or what I did was I just cut the circle in half, knew that this portion right there was low-fat milk, and then the rest of it, I'd have to break it up into 5 equal parts, 1, 2, 3, 4, 5, and each one of these parts represents 10% of the entire circle, right? Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. So 2 of them would be 20% and 3 of them would be 30%. So you could do it either one of those ways. But this is a good way if you ever have really unfriendly denominators that you're working with and you need to figure out the number of degrees, so you can grab your protractor and get to work. Oh, where'd my protractor go? There it is. Pull your protractor down and get to work. I'm just curious. Let's see how well I did. Let's rotate this guy to here. And does that look like it could be about, what did we say it was supposed to be? Oh, I did a poor job. It was supposed to be, this one was supposed to be 72 degrees, and I think I got less than 70 degrees. Oh well, I need to work on my partitions a little bit, but that would be how you would do it. All right, scatter plots, association, and line of best fit. In problems 1 through 4, describe the form, direction, strength, and outliers of the scatter plot. So this is definitely linear. It is positive, and it's not real strong, so I would call it moderate, right? If the points were all hugging that line, that would be strong. There does not appear to be any outliers. This one is also linear, but it's negative and moderate. But this one does have an outlier. This guy is nowhere near the rest of the points. This has no association at all. They're all over the place. There's no way to choose which line would actually work. And then you think about it, your height and your test score shouldn't have too much of a connection. And then this would be nonlinear or exponential, and there's doesn't appear to be, it's definitely positive, doesn't appear to be any outliers, and the points aren't hugging the line, so it's moderate. And then here we go. Here's interesting. It says dry ice evaporates at room temperature. This person's father uses dry ice to keep the glasses in the restaurant cold. Since dry ice evaporates in the restaurant cooler, this person, Julia, we'll call her Julia. Julia was curious how long a piece of dry ice would last. She collected the data shown at the table on the right. Okay, so the time, we're trying to see how the time affects the weight of the dry ice. As time increases, we expect the weight to go down. And where did it start? It started at 15.3 ounces. So that's going to be your y-intercept of your graph. So look at all these points. Once you've plotted them in there, how tight that line of best fit is. This is a very strong association, and it's very negative because as time increases, the weight of the dry ice is decreasing. So as one increases, the other decreases. That's the negative association. So now choose in that line of best fit a couple of lattice points. So I chose this one, which appears to be, what is this? 1, 2, 3, 4. So this one has to be 1.5, and that appears to be 15.5. This one appears to be 5.5 and 12.25. So using your calculators, to go from 14.5 to 12.25 goes down. Oh, wait, no, I chose this one, didn't I? I went with this one and this one. So to go from 14.5 to 10 decreased by 4.5, and to go from 1.5 to 9.5 increased by 8. So it looks like this is the slope ratio as a unit rate. And what that means is, if we're to interpret this, that means that the dry ice decreases in weight, right? Decreases in weight, that's what the negative means. A little over 1/2 of an ounce per hour, okay? And that's fairly constant, fairly, not exactly, because that's not a perfectly straight line, but it's pretty close, that rate of evaporation. So we have, what do we have to do, Drew? What is the approximate equation of the line of best fit? Okay, so here is your Here's your slope ratio. Here's your y-intercept. So now I'm going to do something. I'm going to declare how many hours it should take. This is not a part of the problem, but I'm just going to add this in, because this could be something that you would see on the chapter test. A table of values, you plot the scatter plot, you identify a line of best fit, you pick some lattice points. From your line of best fit, you identify a y-intercept and the slope ratio, and then you create the rule for this situation. So then you have to answer the question. How long will it take? X, when y is equal to 0, when the total weight is no more. Let's solve this problem now. We're going to turn it into a one variable equation because our y is now going to be equal to 0. So I'm going to subtract 15.3 from each side, which makes it a negative 15.3. And then that'll be equal to negative 0.56. So we know we're going to get a negative divided by a negative. So that'll result in a positive number of hours because we're not going back in time. It would not make any sense to have a negative number of hours. So since it's a negative divided by negative gives us a positive, I'm not going to bother with the negatives anymore. 15.3 divided by 0.56. Take about 27 and a third. So 27, what is a third of an hour? It's like 20 minutes. Almost 27 hours and 20 minutes. It should take this entire block of 15.3 ounces of dry ice to completely evaporate. And I feel a high degree of confidence because of the strong association. If this was a moderate to weak association, I would say, oh, plus or minus a few hours. But in this case, I think because it is such a strong association, that is most likely a very accurate, what did I say again? 27.32 hours it should take for all of that to evaporate. And that's how we use statistical analysis with two variable situations where one of them affects the other. All right, that, I believe, concludes Study Guide A. I wonder what is on Study Guide B. I can't remember. Let's go check.
Hey, feeling good.